The question is prove that in any acute angled triangle ABC, c squared is equals to a squared plus b squared minus 2ab cos c. So what do we do? Let's have the triangle. Let's have the triangle. I have the triangle A, B, C. I can say that the opposite side of A, or a side that subtend A, I should call it A, so I'm going to call it A. And the side that subtended C, I will call it C. The side subtended B, I will call it B, or opposite that. So I want to prove that c squared, this c squared, is equals to a squared plus b squared minus 2ab minus c. So in order to prove this, I must draw the height. On the height or perpendicular height, I want to draw my perpendicular height and call it D. Now, because of the angle here is C, you see this angle C here. So this side with the C, I should call it distance D. So this is distance D. This, if I want to prove B, I would have placed D on the side of B. Now, because the whole of this is A, so this side have to be A minus D. Remember, this is the perpendicular height. So to prove this, we need to use the theorem of Pythagoras. We use theorem Pythagoras to prove this. So now remember, theorem Pythagoras works in a what? In a right angled what? Triangle. So now we have two right angled triangle here. I have ADC and ABD. So let me start with ADB. So in triangle ADC, I'm going to say this is my height. I'm going to say my b squared, it is equals to height squared plus d squared. That's what I have. Question 1. So I'm going to in triangle ADB, I've measured my c squared. It is equals to the height squared plus a minus d squared. So I have c squared is equals to height squared plus, because of the squared, I have two brackets. Remember, I have to expand. So c squared is equals to h squared plus, I multiply this, a times a is a squared minus a times d is ad minus ad, then plus d squared. So I have c squared is equals to h squared plus a squared minus 2ad plus d squared. Okay, so I have what? C squared is equals to, I can have a squared plus h squared plus d squared minus 2ad. Now in this situation, I can see that I have h squared, I have h squared plus d squared, which I know from equation 1, that is equals to b squared minus 2ad. So as I'm here, now I can see that I'm going to deal with the cos. So what is a cos? Cos is adjacent over hypotenuse. So I will say that cos c equals the adjacent is d over hypotenuse, which is b. Then now d is equals to b cos c. So this is d here. So that is d there. So I'm going to say this is c squared is equals to a squared plus b squared minus 2a. Then what is d? D is b cos c. Then I've proved my theorem.